Sun wanted to know just what would happen to one of their new Project Blackbox modular data centers if it was at the epicenter of a huge earthquake. So they took it to the UCSD Seismic Response Test Facility to find out how much shaking it could withstand.
The reason we're doing this is to verify the robustness, the mechanical robustness of Project Blackbox. We built this thing to survive a lot of shake and shock, and now we have to prove that it does. But we want to find out the envelope that this thing will operate within, so we want to take it to the extremes and find out.
The Sun is interested to find out what the actual performance of their equipment is under real conditions. And here in California and at many other places around the world, earthquakes are frequent occurrences.
If you're trying to build a new device, which is essentially a portable machine room, you need to know how it reacts in a whole bunch of circumstances.
So this is one of the 4 actuators that we have hooked up to the table, one in each corner, and with the servo controls and then the control computer, we can basically tell the machine to go in any direction we want.
Well, this platform really is capable of simulating 6 degrees of freedom motions. And so all the motions you can see in a real earthquake are duplicated by this machine.
Over the past 2 weeks, we've been subjecting the box to all kinds of different stresses, and we've been learning how it responds.
To simulate an earthquake, you really need a lot of horsepower. For this particular test, we were charged up to about 4,600 psi throughout the system. So it's a loaded bomb, really.
The black box went through its first real earthquake.
So we saw 2 things that occurred that we're going to go fix. One thing is that some screws pulled loose in a cable tray, and so this is how we mount the cables up above the racks. So that shouldn't happen, and we're going to go figure out how to fix that. The other thing that happened is for one of the racks that was very loose, it moved around enough that it got really slammed into the adjacent structures, and some of the grill work in the front of the rack got damaged. So again, a rack shouldn't pull loose like that, but when it does, there are some things that we can do to make sure that it doesn't get so torn up.
Everything stayed running. The failures, most of the failures were associated with power cords coming out. So by and large, the machine did very, very well. There's also a lot of hard plumbing in there. If you shook your own house that hard, you'd probably have a few leaks in it after that effects.
The piping inside of the black box is just fine.
We've gone through this testing and have data to show that we can subject the box to a lot of stress and that basically it'll keep running. All the tests that we've been doing so far have been operational, so we're actually tremendously exceeding what's the normal operational envelope of the box, and yet everything keeps running. What's next is we go back and spend probably a couple weeks really analyzing the data and seeing if there are subtle lessons to be learned from it.
The outcome of the tests were just much better than any of us would have expected coming into it. Machines stayed up in more violent circumstances than we thought that they would stay up. It's a real functioning data center sitting on a shake table. It couldn't have been better than that.